In every field of science, there are some previously used terms which should be considered obsolete due to different reasons, like being ill-defined or ill-used. It is important to be familiar with up-to-date terminology and not use obsolete terms to avoid ambiguity and error. International Union of Pure and Applied Chemistry, or IUPAC, deals with chemical terminology and provides in its publications definitions and recommendations for chemical terms, with special attention to obsolete terms whose usage is no longer recommended. In this regard, one good source is IUPAC's Gold Book with the title Compendium of Chemical Terminology. In version 2.3.3 of this book, published on the 24th of February 2014, about 7,000 terms are discussed, of which about 150 terms are considered to be obsolete. Of these about 150 obsolete terms, 10 terms related to organic chemistry are chosen to be discussed here as 10 obsolete terms in organic chemistry. In alphabetical order, our first obsolete term is Arenonium Ions. Instead of Arenonium ions, IUPAC considers Arenonium ions for cations derived formally by the addition of a hydrogen or other cationic species to any position of an arene, where arenes is the class name of monocyclic and polycyclic aromatic hydrocarbons like benzene or naphthalene. For example, addition of an H plus to benzene C6H6 gives benzenium ion C6H7 plus, which should be called as an arenonium ion and not an arenonium ion. In this regard, it is also good to know that arenonium ions derived from benzene or substituted derivatives are considered as benzenium ions, where benzenonium ions is an obsolescent name for benzenium ions. Our second case is obsolete terms for carbon analogues. Carbon is CH2 and carbons are the electrically neutral species H2C and its derivatives with the general formula of R2C. Carbon analogues are the electrically neutral mononuclear hydrides of group 14 having two non-bonding electrons, the electrically neutral mononuclear hydrides of group 15 having four non-bonding electrons, and also the compound Hb. IUPAC provides specific names for carbon analogues like Germylenes for carbon analogues of germanium with the general formula R2Ge, where some other synonym terms for these compounds like Germylenes for R2Ge are considered to be obsolete. As other examples, carbon analogues of lead having the structure R2Pb are named plumbylidins, where plumbylins is considered to be an older, nor recommended name for them. Also, carbon analogues of phosphorus having the structure Rp are recommended to be named phosphanolidins, where phosphylenes is considered to be an obsolescent synonym for phosphanolidins. Our third obsolete term is carbinols. Carbinols is an obsolete term for substituted methanols in which the name carbinol is synonymous with methanol. Our fourth obsolete term is chemospecificity. IUPAC considers the term chemoselectivity for the preferential reaction of a chemical reagent with one of two or more different functional groups, where a reagent is considered to have a high chemoselectivity if reaction occurs with only a limited number of different functional groups. Chemospecificity is used by some authors as 100% chemoselectivity, but IUPAC discourages this usage. Our fifth obsolete term is glycitols. IUPAC considers glycitols as an obsolescent synonym for alditols, where alditols are acyclic polyols having the general formula HOCH2 CHOH taken n times CH2OH, formally derivable from an aldose by reduction of the carbonyl group. Similarly, glyconic acids is an obsolescent synonym for aldonic acids, where aldonic acids are polyhydroxy acids having the general formula HOCH2 CHOH taken n times COOH, and therefore derived from an aldose by oxidation of the aldehyde function. Also, glycolic acids is an obsolescent synonym for aldaric acids, where aldaric acids are polyhydroxy dicarboxylic acids having the general formula HOCO CHOH taken n times COOH, formally derived from an aldose by oxidation of both terminal carbon atoms to carboxyl groups. In other words, reduction of the carbonyl group of aldoses produces alditols, not glycidols. Oxidation of the aldehyde function of aldoses produces aldonic acids, not glyconic acids. And oxidation of both terminal carbon atoms of aldoses to carboxyl group produces aldaric acids, not glycolic acids. Our sixth obsolete term is isonitriles. IUPAC considers isonitriles as an obsolete term which should not be used for isocyanides, where isocyanides are the isomer HNC of hydrocyanic acid HCN and its hydrocarbyl derivatives RNC. Similarly, IUPAC considers carbylamines as an obsolete term which should not be used for isocyanides. Our seventh obsolete term is mercaptans. Mercaptans is a traditional term synonymous with thiols, compounds having the structure RSH. IUPAC abandons mercaptans, although it is still widely used. Similarly, IUPAC discourages the use of mercaptals as a term for dithiacetals derived from aldehydes. In addition, IUPAC considers mercaptides as an obsolescent synonym for thiolates, and also mercaptols as an archaic term for dithiacetals. Our eighth obsolete term is paraffin. IUPAC considers paraffin as an obsolescent term for saturated hydrocarbons, which are commonly but not necessarily acyclic. In the petrochemical industry, paraffin is still widely used as a designation for acyclic saturated hydrocarbons and stands in contradistinction to naphthalene, where naphthalene itself seems to be an obsolescent term for cycloalkanes, especially cyclopentane, cyclohexane, and their alkyl derivatives. But the term naphthalene too has still widespread use in the petrochemical industry. Our ninth obsolete term is polar aprotic solvent. Polar aprotic solvent and its alternative dipolar aprotic solvent are used for solvents with a comparatively high relative permittivity, greater than circa 15, and a sizable permanent dipole moment that can't donate suitably labile hydrogen atoms to form strong hydrogen bonds, for example, dimethyl sulfoxide. IUPAC considers these terms as misnomers and discourages usage of them, since such solvents are usually not aprotic but protophilic and at most weakly protogenic, where a protogenic solvent is capable of acting as a proton donor, and a aprotic solvent is non-protogenic in a given situation, and a protophilic solvent is capable of acting as a proton acceptor. Also, IUPAC recommends that in describing a solvent, it is better to be explicit about its essential properties, for example, dipolar and non-protogenic. Our 10th obsolete term is retroaddition. Retroaddition is used for the reverse of cycloaddition, where cycloaddition is a reaction in which two or more unsaturated molecules or parts of the same molecule combine with the formation of a cyclic adduct in which there is a net reduction of the bond multiplicity. In this regard, IUPAC prefers cycloelimination to the synonyms retroaddition, retrocycloaddition, and cycloreversion.